In this question, calculate the mass of a non-volatile solute, which molar mass is 40 gram per mole, which should be dissolved in 114 gram octane to reduce its vapor pressure to 80%. So in this question, we have a solution. In this solution, we are using a solute. Its molar mass is given as 40 gram per mole. And this solute is dissolved into the solvent, and the mass of the solvent is 114 gram of octane. So what happened when we are not using any solute, means only the solvent is present, that time its pressure, if we assume as P naught, but when we are adding a solute in the solvent, then its pressure is reduced to 80% of it. It means that the new pressure will become 80% of the original pressure. So we can say it is 0.8 P naught. So now we have to find the mass of the non-volatile solute. So to solve this question, we can use the Rolle's law. So first we write the given values. So according to the question, it is given that molar mass of solute is equal to 40 gram per mole and the mass of octane is equal to 114 gram. So as I said, when we are taking a pure octane, then its partial pressure is equal to P naught. But if we add a solute in the pure octane, then its partial pressure is 80% of pure pressure. So it's equal to 0.8 P naught. Now we have to find the mass of the non-volatile solute. So to find it, we can use the Rolle's law. So we can write it here, applying Rolle's law. So Rolle's law is equal to P is equal to P naught into mole fraction. So this is our formula of a Rolle's law. So here our P is the total partial pressure when we are adding a solute and solvent. This is our P value. And P naught is, this is our original pressure or the pure form pressure. This is our P naught. So we can substitute these two values and we are only writing the pressure of a solvent because solute is non-volatile and non-volatile doesn't follow the Rolle's law. So here we can write 0.8 P naught is equal to P naught into the mole fraction of octane. So this is our mole fraction. So based on that, we can write it as mole fraction of octane. It's equal to 0.8 P naught divided by P naught. P naught gets cancelled. It's equal to 0.8. So now we have the mole fraction. So mole fraction formula is mole of octane divided by sum of the moles of the octane, which is the solvent, plus mole of solute. So this relation we can use it here. So let's first find the mole of octane. So mole of octane is equal to mass of octane divided by molar mass of octane. So mass of octane is given in the question 114 gram and molar mass is also 114 gram. Molar mass of octane is, actually we can find it, molar mass of octane is, octane formula is C8H18. So here we can write 8 into 12 plus 18 into 1. it's equal to 114 gram per. So the same value we substitute it here. Now if we solve it, these both values can be cancelled. So from here we can say that mole is equal to 1. So now if we substitute our values here, so it is 1 divided by 1 plus n of solute. So this n of solute now we have to find. So let's write it here. We already know that mole fraction of octane is 0.8. So we can write 0.8 is equal to 1 divided by 1 plus n. So 0.8 plus 0.8 n is equal to 1. So 0.8 n is equal to 0.2. N is equal to 0.2 by 0.8. So 1 by 4, it's equal to 0.25 mole. So now we have the mole of solute. It's equal to 0.25 and mole is equal to given mass by molar mass. And in the question, molar mass of the solute is given 40. So we have to solve it. Mass of solute is equal to 0.25 into 40. It's equal to 10 gram. So this is the answer of this question.